Good morning slash afternoon slash evening slash night. My name is Ranj Dougal and today we'll be talking about experimental probability. So first let's talk about the question we are going to be answering and doing the experiment on. So the question is, Leonis and Hanuman are playing a game of coin toss. In this game you tell the other player what you think the outcome will be of the coin. The other player does vice versa. If the opponent gets it right, you lose a point and he or she gets a point. If nobody gets it right, then both of you lose a point. However, Leonis and Hanuman had a huge argument. Leonis stated that there was a higher chance of getting heads in the next toss, and Hanuman said tails. Who is right, or are they both incorrect? So, first, what is experimental probability and the definition of experimental probability? Experimental probability is when you physically find the probability of or chance of something. In other words, doing an experiment to find the probability of chance of something is called experimental probability. So we'll be doing the same thing right now. So I have created a chart here in which we're going to be tossing the coin 8 times. So here's an online coin tosser. So to refresh the page, and it's flipping, and heads. So in the first outcome we write heads. And for the second outcome, so let's flip it, heads again. Time for the third time, tails. Heads again. Tails. So 3 more trials. Tails again. Heads. And this is the last trial. Flip it, and tails. So now let's count how many heads and how many tails we got. So we got 1, 2, 3, 4 heads, and 1, 2, 3, 4 tails. So heads and 4 tails. This proves that there's a half chance of getting heads and half chance of getting tails. However, this is coincidental. This cannot or doesn't happen all the time. It's very rare and coincidental to have the theoretical and the experimental probability be the same. So, according to the trials we did right now, we would be getting 4 heads and 4 tails. So what I think we should do would be try this experiment again to see what we got. So let's copy this chart and let's change according to what we get. So heads. So the first trial is heads here too. Tails. So let's change this. Tails. Next, tails again. So that's fine. Next, tails. So we've got 3 tails in a row. We're on the 5th trial now. tails again. It's already tails. And sixth one, heads. Yay! So heads. Tails. And our last trial. Tails once again. So now let's count. We have 1, 2. So we have 2 heads and 1, 2, 3, 4, 5, 6 heads. Like I said before, last time's was coincidental. That's why we got 4 heads and 4 tails. But this time we got 2 heads and 6 tails. So not every time the experimental probability and theoretical probability will be the same. However, in our first trial, both of them were incorrect because both of them had an equal chance of getting heads and tails. However, in the second one, Hanuman was correct because he said that tails would have a greater chance. Therefore, he was correct. So we'll do this experiment one last time to take away any coincidental things. So now let's flip it. We got heads first, so that's fine. Second trial, tails, so we'll have to change this. Third one, heads, so we'll have to change that. Tails. Right now it's a pattern going on heads, tails, heads, tails. Tails once again, so that's fine. And now we're on the 6th trial, so tails once again, so we don't have to change. Let's go for we're on the 7th trial now. Tails, so we'll have to change. And 8th trial, tails once again. So once again, it's become 6 tails and 2 heads. So 6 tails and 2 heads. This proves that according to experimental probability, Hanuman is correct, because in the first one we got both of them incorrect, second one we got Hanuman correct, and third one we got again Hanuman correct. So 2 of 3 times we have got Hanuman correct. Therefore, according to experimental probability, Hanuman is the correct person. So thank you and have a very nice day. Bye-bye.